Welcome everyone to the lecture on the topic of remainder theorem and factor theorem. We are going to discuss these two theorems which are related to one another as one whole lecture. So what does remainder theorem state? Okay, remainder theorem says when a polynomial function f of x is divided by x minus a, that's the divisor, the remainder is always found by f at a. So that means that you need to find the root of the divisor, whatever it is, plug in for x in the equation of f of x, and then you evaluate f of x at that x value. Whatever answer you got would be the remainder. That's what it says. And you may say, what is the logic behind this theorem? I can prove it for you. So imagine that you have this polynomial function f of x. Could be cubic, quartic, quintic, whatever. Okay, when you divide this by x minus a, all right, you end up with some sort of quotient at the end of the day. Okay, let's say if this is a quartic function, you divide it by binomial, you end up with a cubic quotient, right? So I call this q of x, which could be cubic, could be quadratic, could be whatever in different situations. And then end of the day, you end up with some sort of remainder. Now, how do you write the division statement? You say f of x equals x minus a divisor times the quotient, okay, and then plus the remainder. This is a no-brainer. Okay, this is called division statement. In the past lectures, we have talked about them extensively. Now, this equation is not that it's true for certain values of x. It's always true. Left side always equal to right side, no matter what value you select for x. If you select x equals 5 or 6, you plug in 5 here, you plug in 5, 5, or 6, 6, 6 on either side, then left side will equal to right side. We're not saying that this statement is true only for certain values of variable x. We're saying that this is true for all values of variable x. And among millions of values that x could accept itself, x equals a is one of them. So I'm saying that this statement must be true for x equals a as well. So that means that f at a, if I plug in a for x, would be a minus a times q at a plus r. Q at a is actually the numerical value of the quotient evaluated at x equals a. Whatever the quotient is. Let's say the quotient is like x squared plus 1, then this is like a squared plus 1. And if a is 5, it will be 5 squared plus 1. So it's a number. But whatever number that is, if you times it by a minus a, which is 0, it will give you clearly 0. And 0 plus r is r. So that means that f at a is actually equal to the remainder. And that's the proof of the remainder theorem. That's why we say that when a polynomial function is divided by x minus a, the remainder is f at a. That's the reason behind it. Let me give you an example. We have a cubic polynomial. We want to divide it by x plus 7. We want to find the remainder. Okay? Two ways you already know how to find the remainder. One is by using long division. You're going to sit down, spend a couple of minutes, follow the long division procedure, and find the remainder easily. That's one way of doing it. Second way is by using the shortcut method of synthetic division. You're going to do this by synthetic division, find the remainder quickly. Now, this is the third method I'm showing you how you can find the remainder of a division, and that is by using the remainder theorem. So all you need to do is to find f at a. But what is a? A is the root of the divisor. Let's not forget that. So I'm going to find the root of the divisor. So this would be my so-called a value. And now all I have to do is to find f at this a value, which is f at negative 7. And how hard it is to evaluate the function at negative 7. You can do this using your calculator. So negative 7 all cubed plus 7 times negative 7 squared. I'm plugging in. And finally, minus 5. Okay? So you can do the math, and you can use the calculator, see what numbers you get, and I think you will end up with negative 19. So that means that the remainder of this division in only one line, in only a few seconds, you could find the remainder. The remainder is actually negative 19. I want you to verify this answer using both methods of long division and synthetic division on your own at your own time. I want you to verify that this is actually the right answer, okay? Because no matter what method you're using, you should get the same answer. Now, factor theorem is a special case of remainder theorem, believe it or not. It says x minus a is a factor of f of x if and only if f at a is 0. So imagine here we're saying that the remainder is like r, in this case was negative 19. Now imagine if this remainder is 0, what happens? If the remainder is 0, f at a is 0, and when the remainder is 0, it means that the divisor is definitely a factor of dividend. In other words, the dividend is divisible by the divisor. See, in the past lecture, I gave you this example. I said 9 divided by 2, it's like 4 times. 4 times 2 is 8, 1, right? Now, if I say 8 divided by 2, it's going to be 4 times, but this time the remainder is going to be 0, right? So here the remainder is 1, it's not 0, and 9 is not divisible by 2, and 2 is not a factor of 9, but here the remainder is 0, 8 is actually divisible by 2, and 2 is a divisor, is a factor of 8. So that's the difference between these two. All right, using remainder theorem, we found that 1, but now here we're saying that if we don't have 1, instead we have 0, then we can claim that 2 is a factor of 8, or 8 is divisible by 2. That's all we're saying here in simple language. Let's just show that x minus 2 is a factor of this cubic polynomial. So I'm going to find the root of the divisor here. Again, this is the a value, which is 2. And then I'm going to show to you that f at 2 is 0. Now watch this. F at 2 equals 0. We don't know what f at 2 will be. We have to calculate. We have to use our calculators. But if I can show that f at 2 is 0, it means that I have shown that x minus 2 is a factor of this cubic polynomial. In other words, this cubic polynomial is divisible by x minus 2, just like what happened in grade 4. So let me do the math here. 2 cubed minus 3 times 2 squared plus 5 times 2 minus 6. Okay, so that's 8 minus 12 plus 10 minus 6, negative 4 plus 4. Bingo. See, I showed that f at 2 is 0. So because f at 2 is 0, according to the factor theorem, you can say that x minus 2 is a factor of this cubic polynomial. Or you may say, in other words, that the cubic polynomial is divisible by x minus 2, and even if you use the long division method, you will end up with a 0 for the remainder. I hope you understood the remainder theorem and the factor theorem, very useful theorems. And in the next lecture, I have to give you some higher level or advanced examples with longer calculations. Okay, thank you.